Hey, welcome to 2-3. We're talking about how to read graphs today. Once you get the hang of this, it's pretty simple, but it's really easy to get your x's and y's mixed up. So let me review some notation. If I write f of a equals b, what this means, this is actually an xy coordinate written in function notation. The a is your x value, and the b is your y value. So anything in the parentheses when I write a function is your x value, and anything that it's equal to is always your x, is your y. So I could come over here and make an xy chart and say that on this function the point a comma b is on the graph. It's just a fancy way of giving you a coordinate. So what's going to happen in these problems is I'm going to give you one of those coordinates and ask you for the other one based on the graph. So let's start here with problem number 1. We're going to find f of 2. Now notice that the 2 is in the x position. Alright, so that means that I want you to find 2 on the x-axis. This is the x-axis, this is the y. So I'm going over here and finding 2 right there on the x-axis. And I want you to go up and down along that x equals line and figure out where does that hit the graph. It could be above, it could be below. In our case, it's hitting the graph below. And the question is asking, what is the y value associated with that point? So I trace over here and figure out this y value, that's -1. So that's the answer, -1. Right? It could be that I ask you, let's try another one. What's f of -1? So why don't you pause the video and see if you can figure out what that y value is, and then jump back on to figure out the answer. Alright, hopefully you tried that. This -1 is your x value. Okay, so I'm going to go over here now. I'm to -1 on the left. Let me make this a little darker. Okay, and I'm going to go up and down to try to figure out where it hits the graph. Oh, it hits here, and I'm tracing over to get a y value, and so my answer is 4. Hopefully you got that. Okay. Alright, also, I don't have to give you an x value, I could give you a y value. Let's look at how that works. Here I have find the x values where f of x equals 6. So this 6 is in the equal position, that means it's a y value, and I'm asking you for the x value associated with that. So now, instead of finding a number on the x-axis, I'm going to find it on the y-axis. So 6 is up here. And now I'm tracing side to side to see where do I hit the graph. Okay, it's there. And I'm looking for the x value associated with that. So that's going to be x equals 3 is going to be my answer. Or you could write f of 3 equals 6. You're filling in that blank right there for the x value. Alright, let me have you try one on your own. Okay. Why don't you try find the x values when f of x equals 0. So pause that and see if you can figure that out. Okay, so this is a y value. So I'm finding y equals 0. It's here. And I'm tracing my horizontal line across y equals 0 to say, where does this hit the graph? Well, this actually hits in 3 different places. That can happen. Now I'm going to have to estimate these numbers, okay? They're not right on the line, but that's all right. So I'm going to say x equals, this one is like maybe -1.7. This one looks right on at 1. And this one I'm going to have to estimate, let's say 1.2, somewhere around in there. And those are my answers. So you can have multiple answers on these. Okay, now This problem, where is f of x less than 0? So again, this 0's in the y position. That means I'm looking to split this graph at y equals 0. So again, here's 0. Y equals is always a horizontal line. Hey, let's review that really quickly. Okay, here's a little quick review. If I have y equals a number, these are horizontal lines at the value that the y dictates. If I have x equals a number, these are vertical lines. So when I'm giving you the x value, you're finding it and drawing a vertical line. When I'm giving you a y value, you're finding it and drawing a horizontal line. So that's why I'm drawing horizontal here at y equals. And this is saying, hey, where is this graph less than 0? So what that translates to, what we would say in English is, where is the function below y equals 0? Okay, now, whenever I ask you where, that is asking for an x value. So the way I remember that is this. Let's take a look over here. I come to you and I'm like, oh my gosh, you'll never believe what I just found. I found a treasure map. Okay, and here it is. Here's my treasure map. That's a palm tree in case you don't know. We'll draw some birds in the air. Here's water. And then the treasure map says, hey, that is, what is that? That is where the treasure is, right? How do I mark where the treasure is? I put an X on it. So where, if I want to know where is the treasure, that's an X value. All right? That's how you remember it. You're welcome. All right, so X value, where is the function below y? So I'm looking at where is this function below that teal line. Okay, it's below here. Sorry, that doesn't show up very well. It's below here and it's below here. Okay, those are the places that the graph falls below the teal line. But I want to name those locations with X values. So here's my X values. From here over, right? And from here to here. Those are the places that mark the green sections. So the way I write that in Mathland is I say, well, it's everything less than, we called this point right here, we called this point negative 1.7. We called this 1, and we called this 1.2. Again, estimates, okay? But what I'm going to say is, well, it's less than negative 1.7, so I write negative infinity to negative 1.7, okay? That interval unioned with 1 to 1.2. Now this notation, it's the first time we've seen that in this class. You did that in Algebra 2. This is instead of writing x is less than negative 1.7 and x is between 1 and 1.2. Whoops. So you remember that notation from Algebra 1, and we're transferring now to this notation, this interval notation. Now, I can review that a little in class if you need to see that. So make a note to ask a question about that if you need more explanation there. But there's one more thing we need to adjust on this interval. The question is, I drew round brackets just for now around all of these things, but are they all supposed to be round brackets? And the way that you tell is based on the problem. Look at what the problem originally says. It says, where is f of x less than or equal to? That line underneath says that the 0 spots are good. They're included. So inclusion is a square bracket. Now, every time I write infinity, this is not an actual number, so I don't actually get to negative infinity. So the infinity guys are always round. But the numbers in this case are included. So instead of round brackets, I'm going to come back and I'm going to do square brackets around the number. Now, if it had said f of x is strictly less than 0, everything would have been round. That's how you decide between those two. Okay. What if I said on this, where is f of x greater than 6? All right, let's take a look at that. You could pause the video. You can try that on your own if you want. All right, hopefully you took a look at that and took a shot. Hey, if you don't try and make a mistake, you don't learn. So you've got to pause the video and try it to really get the most out of these. That's what we would be doing in class, is I would be giving you a problem and then I'd be walking around while you do the problems. So you really need to practice in order to get the most out of this. All right, so 6. 6 is a y value. So I come up here and I find 6. I'm drawing a horizontal line to split my graph. Whoa, that's supposed to be one line. And I'm saying, where is this graph above the orange line? Above because it's greater than. So it's above right here, this section. Okay, now where does that happen? I need x values. So let's go down. Let's take this value and figure out what the x value is. 1, 2, 3. So it's 3 and everywhere to the right of 3. So that would be x is greater than 3. So I would write 3 to infinity. Now let's check our brackets. This one's always round because it's infinity. This one is a question mark, and it's dictated by this sign. This is a strictly greater than. So in this case, it doesn't include 3. And so I keep it as a round bracket, and that's your answer. Okay. Next one. Which is larger, f of 1/2 or g of 1/2? So these are in the x position. So I go to my x-axis and I find 1/2 right here. And I draw a vertical line because it's an x equals line. And I am comparing this value, this y value, to this y value. Which one is larger? And so I go, oh, it's the blue line, and the blue line is named g. So that's going to be g of 1/2. Okay. So these will look similar. The difference between this problem and the previous is now we're comparing two graphs instead of just looking at one. But the ideas are the same. Okay, so we'll move a little faster through these. The next problem says, well, let me erase this. Says, for what values is f of x smaller than g of x? So where's the red graph below the blue graph? That's what it's saying. So here is the section where the red graph is underneath the blue graph. And it says for what values, that translates into where. Where does that happen? It's another way for me to ask you where. So I'm looking again for x values when I ask you where. It's between this x value and this x value. So between -1 and 1. Now, does it include -1 and 1? Well, the sign says or equal to. So that means that we're going to do square brackets on these guys from -1 to 1. That's your answer. Okay. For what values of x does f of x equal g of x? So that means where do they intersect? Let's write that. That's helpful. Where do they intersect? If, anywhere along this lesson, if I write something down you didn't know, like translation-wise, you should put it on a note card. So on the front, I would write f of x equals g of x, and then on the back I would write that's where they intersect, because it's helping you memorize a conceptual idea associated with the math language. All right, so I go into here and I go, okay, where are these guys touching each other? So here, and here. And again, it's where do they intersect? So I'm looking for x values. Now this is not an interval because they don't touch all the way through between -1 and 1. They only touch at -1 and 1. So I would write x equals -1 and 1. Just a list of values. All right, last graph here. Intervals on which the graph is increasing. All right, we talked about this before, but a graph is a roller coaster. You get on the roller coaster on the left-hand side. Okay, there we are. And when you're increasing, you're going up. When you're decreasing, you're going down. So I'm going up the roller coaster here to the top, and then I'm going down to the bottom, and then I'm going up again. So this is your up part, this is an up part, and this is your down part. So where am I increasing? It's where I'm going up. And again, it says where. So I'm looking for an x value. And these are going to be intervals. So -2 is here. This is a 1. So I'm going up anywhere to the left of -2 and anywhere to the right of 1. The way we write that is -infinity to -2, that's the left, and 1 to infinity. Now, what about these brackets? It depends on what book you're using. I'm fine with you just leaving all of these round. Some books say that this high point is both increasing and decreasing, and they square it off. And some books say neither. So I just, as a convention, always put those as round brackets. Next question, where is the maximum? So in this problem, we're assuming this is talking about a local maximum. And what a local maximum is just where's the high point, like within the graph. There's not an overall maximum in this graph because it goes on forever. It's like, we call it an absolute maximum in calculus. There's this graph keeps going up and up and up, and so it doesn't ever stop, so I can't actually name the highest point of the graph for you. But we can look at what's called a local maximum, and that's just where is there a high point in this part of the picture. And you'll define that formally in calculus later, but for now that's our definition, is just where's the high point in this area of the graph. And we'll be talking about local maximums when we're doing these problems. So I go, well, let's see, here's the high point. It's the place where the roller coaster changes directions from going up to going down. And when I ask you where is it, that is asking you an x value. So here I am at -2. That is where the maximum is. Now, different question, be careful here. What is the maximum? When I ask you what I'm asking you, remember our treasure map? Yeah? I'm asking you what is in the box. We found the box at X, but what's in the box? How much money did you get? Okay, so it's measuring how high, how much, or how little, what's in the box. So what this is asking for is a Y value. What is the maximum? How much money did you get? How much money did you find at the location of X? And that is 7. So I say Y equals 7, or you can say the max is 7. Okay? All right, lastly, I'm going to talk to you about the calculator and how to graph some of these and calculate maximums on the calculator. I am going to give you a strong push towards class calc. When you're calculating things like maximums, they're a lot easier. but it is your choice which one you want to use. I'm going to start by explaining the TI, then jump over to class calc, and you can compare. If you're going to graph something, like let's say y equals x plus 2 times x minus 1 times x plus 5, what you're going to do is you're going to go into this y equals button. When you do that, it's going to say y equals, and then you type in your equation. Make sure your parentheses are right here that you're using, and your x is right here. That's how you graph it. And once you get your graph, you're going to calculate, the directions will say calculate the max or the minimum. Okay, so I'm going to outline this for you, and then I don't have an interactive calculator on this app, so I can show you in class how it works if you want to walk through the details, but I'm going to kind of outline the steps. What you want to do to calculate the max and the min is you're going to hit your second function and then your calculate button. See that blue right there? The second function accesses anything in blue. So second function, and then that blue says calc. That's calculate. And when you hit that, you're going to get a screen with a bunch of options in it. And the one you're looking for is min, max, or it could say extreme. Okay, depending on what calculator you have. And you're going to select that, and it's going to kick you to your graph. Okay, I haven't graphed this yet. We'll do it in a second, but so I'm just estimating. You got some graph here, and what it'll say down here is left bound. What that means is use your arrow buttons to move. There's a blinking light to the left of your max. Here's your max. Okay, this is what we're trying to calculate, and so I want to move the blinky light along the graph until I get somewhere to the left of the maximum, and then you hit enter. And then it'll say what's your right bound. And so you use your arrows to move the blinky light to the right, and you hit enter again. And what you'll see on your screen is it'll put these little arrows right here. Okay? And your max should be between them. And once you put enter, then it'll say guess, which means put your blinky light where you think the max is. And so you move that over and then hit enter again. And then down here it'll say x equals and y equals. So this is where is your maximum, and this is what is the maximum. It'll give you an x, y coordinate at the bottom. Okay, so that's how you do the TI. Now let's jump over to class calc and talk about how to do that here. The first thing you want to do on class calc is up here on the calculator bar. You want to make sure that you're in graphing. Okay, that gives you all these options, and this is kind of your place where you type things. So we're going to type y, okay, equals, and then we're going to type our equation. So let's go x plus 2, and then x minus 1, and x plus 5. Okay. Now, if you need to find your graph, sometimes you can't see it because you're off out of this window. This little guy, this little grid, if you tap that thing, it'll center it for you. Okay, so here we are. And if you want to zoom out or in, you can use these plus minus, but you can also use your fingers to pinch and expand just like you would on a touch screen. Okay, which is one of the reasons I like it. On a TI, you have to actually go in and change the window settings, but this just zooms. You can touch it and move it around and all sorts of stuff. Okay. Now, say I want to calculate the max and the min on this. Here's how cool this is. You just go up here with your finger and you just tap where the maximum is. And see that little gray dot appears? If you touch that again, it gives you the coordinates. So that's pretty cool. This is where it is at negative 3.7. This is what it is, 10.3. All right. Down here, if you want to calculate the minimum, you just tap that. Make sure you're tapping, expand it, make sure you're tapping the right one. Because one of those gray dots is the y-intercept. See, this is the y-intercept right there, and this is the minimum. So make sure you're tapping the correct one, and that's at negative 2.6. So again, you can do y-intercepts. You can come up here and you can calculate your x-intercepts too if you want to know those. That'll give you coordinates for all of those. So there's no like going into a menu and all that stuff. You can just tap those guys and do it. So that's pretty cool. I want you to use your calculator to check your answers. Some of the problems say use a calculator, but some of them don't, and I want you to do the problem by hand, make sure you understand what's going on, but use your calculator as your tool and get used to checking your answers with it. It's really it's going to be a really powerful help in calculus if you know how to use it. So we'll walk through that as we go. Okay, so that's how you do min and maxes on both calculators. Do your homework.